Hey everyone! In our last video, we took our first steps with AWS Lambda, creating and running a function within the AWS Management Console. Now the console, it's a good place to start, but when you begin building more complex applications, you want a more powerful and efficient workflow, and that's where local development comes in. Think of it like this. You're writing your function in the console. It's like editing a document directly in your web browser. It works, but it's basic. Moving to a local setup with an editor like VS Code is like upgrading to a full-featured word processor on your computer. You get better editing tools, easier testing, and overall a smoother process for making changes. So today we're going to bridge that gap. We'll set up our local environment, pull a Lambda function from the console into VS Code, and establish a cycle that will involve editing, testing, and deploying that, all without leaving our code editor. Before we dive in, let's quickly cover what we'll need to follow along. We'll be following this AWS article on Lambda local development. It lists prerequisites, including installation of VS Code, the AWS Toolkit for VS Code, AWS credentials configured, and I'll be using a profile that I've already set up when I configured AWS CLI with SSO. The toolkit will automatically pick this up from my config file that AWS CLI set up. For this demo, I won't be using SAM or serverless application model, as well as Docker. We'll be exploring that in future videos. So if you've got all of that, let's get started. I'll create our Lambda function via the console. Use Hello World Python. Again, I'll be using Python as our runtime. Leave the defaults as is. So that means our IAM execution role will be just the one that AWS Lambda will be creating for us, which means it's only got permissions to publish to CloudWatch. And here is our IAM role. It's got that basic permission to create log stream and put log events into CloudWatch. Here's our function created. It's got the boilerplate template. And if we click on this Open in Visual Studio Code, it's got some instructions on configuring AWS CLI credentials. Here's the location of that config file. And we'll click on Deploy. Our browser is just asking permission to open this application, which is VS Code. And once we open this, because I haven't installed the AWS Toolkit extension, it's prompting me to allow that installation, which I'll do so. So it's now presenting me with an option to use what it found in that config file as the possible access or profiles that it will use to access AWS. For this demo, I'll be using my Sandbox 2 profile. If I click on that, it's already signed me in because I've had a previous session to sign in. So here's our Lambda boilerplate already downloaded from the Lambda console. It's great. It's given us this preview, this README, telling us what we can do and how we explore, edit the Lambda function. So we now see this icon AWS. Click on that. That is the AWS Toolkit extension that we've just installed. And it takes us to Explorer. You can see the different resources that we can see from within our local VS Code editor. I'll expand Lambda, and here it shows me the Hello World Python function that we've just created. Expand that, and you can see the single Python file that we have. So from here, I can invoke remotely by clicking on this triangle sign, and it presents me with options on what payload I want to send. It can be just an empty one because this is just basic. It's not expecting anything. If I click on remote invoke, I can see straight away the logs from, and this is the logs that get sent to CloudWatch too. So the same basic logs that we can see with that hello from Lambda. I'm now going to paste that code that we used in the last demo, which gives us the context information from Lambda. So once I pasted that, and for the benefit of those who haven't seen the first video, what we've done here is expand the basic boilerplate template so that we have a better understanding of what Lambda, this Lambda handler function, expects, which are two parameters named an event object and a context object. The context object contains several values in there, such as the runtime information, the function name, details on the remaining time for our Lambda runtime, and memory limit for our function. And all we're doing is saving that into a JSON called response body and returning that. So if I click on save, you can see on the lower right, it's prompting me to deploy. So I have the option of not deploying or deploying. And for now, we'll deploy it. We can see straight away that it's uploading to Lambda. And straight away, we can do the remote invoke from here and see the results. See how quick that is? This returned to us all that information from the context object. And if we have a look at our Python function, refresh this screen, we can see our updated code on AWS. Okay, let's take this one step further. We're going to expand our Lambda's functionality by having it email us the response. To do this, we'll use another AWS service called SNS, or the Simple Notification Service. I've already pre-created our SNS, and if I just zoom in here, there's this overview of Amazon SNS gives us a quick idea of what its capabilities are. So you can do an application to application or application to person. And in my case, I want to do an application to person first to show you the integration of Lambda to SNS, which is another AWS service. When we think of SNS, it's just a messaging service. You give it a message and an address, which AWS calls a topic. And think of an SNS topic like a mailing list or a bulletin board. SNS then delivers that message to anyone that subscribed to that topic, whether it's an email address, an SMS message, and it can be another Lambda function as well or other services. I've already set up the SNS topic and subscribed my email address to it, which is this one. So we're ready to go. Okay, here's the catch. By default, our Lambda function is isolated. For security, it cannot interact with any other AWS services. It's like a new employee who doesn't have a security badge to access different departments in a building. And we need to grant our Lambda specific permissions to talk to an SNS. And we do this by updating its IAM role. And luckily, I have that already open here. But if you haven't, you can identify the execution role of your Lambda function by going to configuration and this permissions tab, click on the role name, and it will open up that IAM role for you. As you can see, we only have the basic execution role. So we just add a permission. Will you be using create inline policy and select the service, which is SNS. For our case, all I need is to give it that publish permission. Remember the principle of least privilege. You have the option of giving that sns.star, which is a wildcard, meaning you're granting all permissions, all of these more than 20 or 30 permissions to your Lambda execution rule. But to follow the principle of least privilege, we just want to give it the specific permission that it needs, which is this publish. And I want to scope it further to not just all SNS resources in my account, but just to a specific account. I'll add the ARN, get the ARN of my SNS topic, click next, give it a policy name, SNS publish, and that's given our Lambda execution role that permission to talk to SNS, specifically to publish and to that SNS topic. Okay, now let's go back to our Lambda function, and we'll be updating our function by first importing Boto3. See, there's already that autocomplete. It knows already what I'm gonna be typing, which is the good thing or the benefit of using VS Code. And you can add all the extensions that you need to make your workflow smoother and easier. Okay, so you might be wondering, what is Boto3? We're using the Boto3 Python library, which is the AWS official Python SDK that lets our code communicate with AWS services. It's already available in the Lambda runtime environment, so we don't need to install anything. And I'll copy and paste what I've prepared as my code for talking to SNS. So after we build our response body, I want to paste in my code here to send all that information to SNS. And let's just fix the tabbing. Okay, notice I've wrapped the SNS call in a try catch block, rather a try except block. And this is good practice. This means that if something goes wrong with sending the email, our function will log the error but still return a successful response. The email is nice to have, but it should not break our main function if it fails. And if we look at the try block, all we're doing here is building our SNS client, defining our topic ARN, and then calling that client's publish function, giving it the topic ARN, just a subject, and the message, which is our response body. Okay, we're ready to save and deploy that. I've saved it, click deploy, wait a few seconds, and we can see that it's already uploaded the code to Lambda. Click on this triangle to remote invoke. If I go to my email here, I can see the message from Lambda with our response body, hello from VS Code, and all that metadata from our context object. And that's it. Let's recap what we did. We installed the AWS Toolkit in VS Code. We connected it to our AWS account, downloaded the Lambda function from AWS, and we established a smooth local development loop that edits, deploys, and tests our function all from our editor. Finally, we expanded its capabilities by granting it IAM permissions to publish to an SNS topic. This workflow is a bit of a step up from the console development that we did in the previous video, and it's all fundamental to building serverless applications in the real world. In our next video, we'll take the next logical step and explore how to manage our Lambda function and its configuration as code. Thanks so much for watching. I hope you found this helpful. I'll see you in the next one.